This is Mr. Anderson for Kellogg Community College, and today we are going to look at section 9.1, and we're going to take a look at the p-test variant, and normally this would be a z-test using two independent groups, but we're going to compare and contrast what we did in the previous video, which is using the z-test to compare two different independent groups, and we're going to look at the p-test variant. Now, to review some of the p-test stuff, the p-test kind of works similar to the t-test or the z-test, except we're going to compare the test score to a percentage. Now, the best way to kind of compare and contrast is let's actually do the problem as if it was a normal z-test. And then after we do that, we'll show you how it's done with a normal p-test. So let's first start off by reviewing the z-test steps. Now, the first thing we will do is we will get a null and an alternative hypothesis. This is the same actually in both of these. The null and alternative hypothesis will look identical. The second step of a z-test is where we find the critical value based on the alpha that I'm given in the problem and whether it's a 1 or a two-tail problem. And the third step will be to use the formula. And the formula is on your formula sheet. The fourth step is to draw a picture. The picture will have a normal curve, and it will also have the number of standard deviations away the critical value is, and we can compare that to the formula, and then we're going to write our summary statement about whether we are going to reject or not reject the null hypothesis. Now, in the p-test, we actually don't do the critical value. What in fact we do is the formula. So the formula that we do in the third step of the z-test is the same formula we use in the p-test. But then what we're going to do is we're going to take that formula and we're going to check the z-chart to see where it is. Now, we turn that into a percentage or decimal, and then what we do is we evaluate the decimal. And there was a chart that I made back in the Chapter 8, Section 2, and I will review that chart with you. And I'll check to see if this formula's decimal is lower than the alpha that the p-test started out to evaluate. And then we'll write our summary statement. So seeing these side by side is really going to help you kind of like look at the similarities and differences in the p-test versus the z-test. Most of the time, we're going to assume that alpha is going to be 5%. Now, it will tell you in most all of the problems in the book what the alpha is, but in case it doesn't, like in this example where there's no alpha given, always assume alpha is 5%. So we want to be 95% sure we're not making a type 1 mistake. So here's the problem, and I've got this kind of squeezed in here so we can see all 5 steps on both sides. And I want to start off with the z-test like we did in the previous videos to show you what we are going to do. So in this example, we're checking to see if these colleges, these 30 colleges, offered more sports for men than women. So these two independent groups, the male had a sample average of 8.6 sports offers per college with a standard deviation of 3.3. It looked like the female sports were offered a little bit less on average. The standard deviation was the same. So we're going to call this my mu sub 1. And I'm going to call that mu sub 1 because since we're going to have to compare if men were offered more sports than women, I want to use this relationship for my null and our alternative hypothesis. Now the null hypothesis is going to be where mu sub 1 is equal to mu sub 2. This is saying that their sports are equal or not statistically significantly different. My alternative to say is that there's more men or more sports for men offered than women. Now we can see that that is actually the case if we just look at the averages. But looking at the standard deviations between the two of them, is this statistically significant with an alpha of 5%? So let's continue on with doing the typical z-test for this these two independent groups. Now the second step is to find the critical value. Here's what we know. We know the alpha is 5%, and since this is going to check to see if group 1 is bigger than group 2, then this is right tail. Now the right tail problem means that we are going to look up 0.9500 on my z-chart, which is going to be on the right side of the z-chart, and this means my critical value is 1.65. So now I'm going to run my test value. Now I'm not going to actually show me typing this into the calculator, but it's the mu1 minus the mu2, and I'm going to keep that order the same because this will also give me a value that's on the right hand side of the z-chart page. And I'm going to be very careful. I would probably take this denominator in several steps, taking the standard deviation of the male group and then adding the standard deviation of the female group divided by the sample size. I'd probably compute all of this first, then take the square root, and then get that number and use that as my denominator. My numerator would be 8.6 minus 7.9, get that answer, and once I know my numerator divided by denominator, it would give me an answer of 82 hundredths, or 0.82. Reminder, this is a z-score, and it is not a percentage. This is not 82%. Now for step 4, we're going to draw a normal curve. We're going to put in some markers. I first want to mark my critical value, which creates my critical region. So if this is 0, 1, and 2 standard deviations away from the norm, I'm going to put a flagpole at 1.65. So at 1.65, this is where my critical region begins. And this is a right tail test, so I'm going to shade to the right. The next thing I'm going to do is I'm going to evaluate that my test score came out at 0.82, which is a flag about right here. Now I'm noticing that my 0.82 was not actually inside of the critical region. So since that's the case, we will make our summary statement. Since 0.82 is less than 1.65, we will not reject the null hypothesis. Because we would need to be inside of the critical region to reject the null hypothesis. So we're saying that, hey, I do see that there are slightly more, not actually even one extra sport on average offered for the men, but according to the standard deviations and this being significantly, it is not statistically significant for us to reject the fact that we have equality there. So now we're going to look at the p-test. Now the null and the alternative is going to stay exactly the same. We can keep up by saying that the null is mu1 is equal to mu2 and the alternative is mu1 is greater than mu2. Now what we're going to do for step 2 is to use the test value. Now since we have run the formula here, we're going to use the test value here, and I'm not going to rewrite the whole equation here in part 3. But I'll just say the test value is 0.82. This is going to be on the right side of our two-sided page, two-page z-chart, and what we're then going to do is we're going to look up 0.82 for z. And what I'm going to do is evaluate the decimal. Now the decimal that I found at that moment is going to be 0.7939, or 79.39%. Now, the chart that we built back in section 8.2, and this is true for all z-charts, the chart that we built said, first of all, if it's one tail, you don't have to double it. That's only for two tails. But if it's one tail and it's bigger than 50%, you have to subtract from 1. So if the decimal is greater than 0.5000 or 50%, subtract from 1. And what we will do is now that 1 minus 0.7939, which is 0.2061, or 20.61%. So this group was definitely in the top 20%, but it still was not small enough or outlierish enough to basically crack that 5%. Because when we evaluate a p-value, we're checking to see if this group was in such an extreme position, and actually in this case lower than the 5%, then we would, say that we can reject the null hypothesis. See, that's the thing about p-testing. We basically set our p-value based on the alpha. In this case, our alpha is 5%, which means that if our data set is within the top 5% or bottom 5%, depending on whether you're going greater than or less than, if it's in that top 5 or bottom 5%, then we have to reject the null hypothesis because this group was so far away from the norm. But this isn't, it's not exactly in the middle. It's not at 50%, but it's not far enough away to say that we're going to reject the null hypothesis. So here's our conclusion. Since 20.61% is, I don't really need the word is because I can just use the word symbol greater than, is greater than 5%, which is my alpha, we will not reject the null hypothesis. So this brings up an interesting, and my last comment before this video ends, is that your conclusions for p-tests and z-tests using the same data should be the same result. Yes, I know we're here talking about in step 5, we're talking about comparing z-scores, and here we're talking about comparing percentages. That's why this is called the z-test, comparing z-scores, and p-test, comparing percentages. But the results are the same. I think you're going to see more of these in the wild, like if you're actually looking at things in journals or things written in newspapers. The p-test is a little bit easier to translate for people, even though I feel the z-test is easier to compute once you know what a z-test is. But how many people know what a z-test is in a newspaper or some kind of report? So they'll probably turn this into the percentage and say something like, well, it looks like this study showed that this group was in the top 20% or bottom 20%, but still not in the top or bottom 5%, so therefore we're not going to reject the null hypothesis. So I need to give you that exposure to those p-tests because on the test itself coming up, you're going to have a p-test from either section 8.2, 8.3, or 9.1. So thank you for watching. I really appreciate it. And again, if you've got questions, shoot me an email to my class account, and I appreciate you watching. Thank you.